Hi guys, we are live. So today, as per plan, the idea is that we are going to explore geometric deep learning, mathematics, the need of mathematics in deep learning. The idea. Hopefully, are still live. Internet is work fine. So the idea is we're going to talk today is why are we uh, what exactly is learning, how it affects how it is affected by mathematics. That's the idea. All right, pinged everyone in my Discord, waiting for them to join. Show my live. So I'm trying to open this book. Not able to open it for some reason. I'm not really sure what the problem is. Can I get PDF? So this talk, what we are going to discuss today, will be about the issues which the new data or deep learning engineer has to face when he starts to learn deep learning. So what happens is that once you start a complicated subject like deep learning and don't take it up properly mathematically, the issue becomes that you end up knowing something but you don't truly understand it. So there is a lot of difference between knowing something and understanding something. So knowing essentially is about, so for example, there is a very good talk which I mean, it's not a talk, it's a uh, Richard Feynman said that if you are pushing a cart and you know that this is inertia and how friction works and stuff like that, even a kid knows what exactly happens when you push a cart, but does he truly knows friction and does he truly understands um, the meaning of the words? That is extremely important to understand. If you want, I can share some materials with you. So there is a I had made a video itself, knowing versus understanding. There was a good blog which I had read about this topic. So I think it was this one. So until unless you understand um, any comments on Zillow fiasco, I'm not really sure if you are on right channel. The channel is for AI, so we will be focusing on that. Cool. Um, yeah. So the difference between knowing and understanding is critical because we end up knowing a lot of definitions. For example, people know that features are extracted when neural networks learn something. But what type of features are extracted? From where features come from? So ideas like that uh, can truly be understood once you have got a mathematical backing of things. So that's there. That's why I decided to come live and talk to you all about deep learning and impact of mathematics and stuff like that. So the more you dive deeper into the field of mathematics, the beautiful the understanding of deep learning and artificial intelligence becomes. By the way, mathematics is not just about numbers. Mathematics is an art of logically explaining your thoughts. That is about that is the meaning of um, mathematics. Okay? So I'm just asking my guys. So, so yeah, so that is about mathematics. So what we are going to do today is we are going to explore new areas of deep learning and mathematics and understand how does these things work together and how much maths is required to truly understand deep learning. By the way, I'm not sure how many of you are here. I can see 3 people watching. So it'll be awesome if you can drop a hi and let me know who you are so I can address you as well. So moving forward, there is a new field which is coming known as geometric deep learning. So geometric deep learning is a recent phenomena, and I guess it was Michael M. Bronstein. I'm not really sure. Let me pull him because this guy. He recently got a promotion as well. Congratulations to him. So the idea behind geometric deep learning is heavily inspired from mathematics. The idea says that if you, um, I'm not sure if you all know about something known as um, Erlangen program. So it's similar to, if you are a programmer, you might get confused. An Erlangen program is not related to Erlang. Hi Prashant, nice to see you. It's not related to Erlang. Erlangen program is an approach which came from the history of mathematics, where people said that if you so there was a time in maths which was very interesting. At that time there were various fields of um, geometry which were available. There was Euclidean geometry, there was Gaussian geometry, Riemannian geometry, non-Euclidean geometry, and tons of different fields like that. So in that case, there was a fight, right, among mathematicians that which field of geometry is the ultimate truth, because in maths we search for ultimate truth. So ultimately, this guy named Felix Klein, he came and he was a professor in a university in Erlangen. So he came up with a program where he proposed how do you, using group theory, which is a subject in abstract algebra in mathematics. So how using group theory you can actually tie up various geometries in such a way that they come out to be related. Okay, so that is the whole idea behind Erlangen program, and similarly, that is the premise for for geometric deep learning, and that is why I used to say before, and now I have started to even strengthen up my discussions around this. Why understanding of geometric deep learning is important, or why understanding of mathematics is in general is really important, because the sooner you understand the importance of maths, the more you will try to reason about or pay attention to these new fields which come up. And often they try to solve a very basic problem, but in order to understand that problem you have to know your maths out. Now what does math mean? So that we can also discuss. Mathematics essentially, as I have said, is a study of logic, breaking down logic into in such a way that it can be proved using some sets of tools which are available. So you have got some axioms in maths, you have got some lemmas, you have got some some things which are assumed, right? So there are some axioms in set theory, there are some axioms in geometry. On that axioms, you try to establish your logical fact which you are trying to say. If you can do that, you are doing mathematics and you are trying to establish something. So that's the idea behind maths. Usually what happens that when we are young and when we start learning about mathematics in school, the way maths is introduced to us um, is not something uh, which seems friendly, right? Because a lot of time I have heard people that what is the point of studying trigonometry or calculus? We are not going to use it um, on our day-to-day basis, right? The issue is all of those people end up studying deep learning most of the time because they are engineers, and since they want to study deep learning, if they don't understand those maths of differentiations, chain differentiations and stuff, it will be extremely hard to get to the first principles of a difficult subject like deep learning. So that is why I stress a lot on understanding of the subject, mathematics. So meanwhile we are here, I want to ask some questions, rather scratch the that part of your head where I want to say that, do you know why exactly we use real numbers in in deep learning? So what happens is that your weights of neural networks, your your learning rate, all those things are essentially real numbers. And you want, as a deep learning engineer or someone who works with these things, you ultimately want um to make sure that the loss reduces and your neural network trains. So if your loss has to reduce, the meaning of reduction should exist in the first place, correct? So the meaning of reduction comes from the idea of real number spaces or metric space. If you use complex numbers, or if you are dealing in a complex number space, complex numbers don't have an order. Real numbers do, which means that 2 is less than 3, 2 can be greater than 3, 2 is equal to 3. These things mean something, right? These things don't exist when you take complex numbers. So for example, there is no way to for you to tell me that whether 2 is equal to 3, 2i equal to 3i, or 2i is greater than 3i, or 2i is less than 3i, or maybe we can go even complex, which is bigger, 5 plus 3i or 3 plus 5i, right? There is, it's very hard to do that. And since there is no order, how will you reduce something? Because in order to reduce something, you have to have order. So that is why we don't, I mean, that's what my understanding is, that we don't use complex numbers for that specific reason. There is another thing, which is that real spaces, real numbered spaces. So these ideas come from metric spaces in mathematics. The real number spaces gives you um, what do you call, the guarantee that your Cauchy sequence is going to converge. So that is why real number space is known as a complete space. So what happens is that if you have a Cauchy sequence, so what is a Cauchy sequence? So think of it as a wave which is essentially reducing as it is moving forward in time. For example, it starts very big like this, but it is reducing, okay? So there is a guarantee that if you do this in a real metric space, you will converge to most likely zero, but to a number. So if you know your deep learning, you know that when you train a neural network, your neural network also behaves like this. Neural network also starts with a very high loss, then you come down, and then you wiggle a little bit, and finally you have to converge to a point. So if you don't use real numbers, it there is no guarantee that your neural network is going to keep reducing, or it is going to converge to a point if you train it to infinite. um, if you keep training the neural network to infinitely many epochs. So that's the idea. That's why we use real numbers in uh, that's why we use real numbers in deep learning. So let me know if that was interesting for you, that you actually understood why do we use real numbers in deep learning, or did you think of it before? Let me know about that in chat, and also send me a hi so that I know that you are here and you mark your attendance with me. So, by the way, this is not something which I'm making up. So, there are complex valued neural networks, because complex neural networks give you some special things which no, your normal neural networks can't. So, what does complex neural networks can give you? So, one simple thing I um, can say is that complex numbers have got an ability to rotate, um, right? Which means that if you take a number and if you multiply that number with some quantities, if you take two, your two can rotate. Actually, you have got conjugates in complex numbers. So that conjugacy is not there. um, the conjugate numbers don't exist in real numbers. So if think of it in an intersection of computer science, mathematics, biology, right? Um, Hi Antara. So the idea is that if you have got conjugates, your and if that can rotate, that's what my assumption is, that instead of building a direct acyclic graph, it means that your first neuron is connected to the second neuron. That um that connection is not there always. If your neural network, if the weights can rotate, if they can have conjugates, the second layer of neuron can also talk to the previous layer in the forward propagation only. It makes the whole thing little complex, but yeah, I mean, um, this is something which we can think about, right? It might be useful of some things, because real numbers are not enough to do all sorts of things. For example, if you are playing a lot with quantum mechanics, if you are playing a lot with remote sensing, satellites, you have to rely on complex numbers to give you those guarantees of what universal approximation theorem and stuff like that. That does not exist in the world of real numbers, as per me. There is no like theory about it. You have to have a mathematical inclination and then think about these things to come up with these ideas. So yeah, I know it was quite fascinating to me as well, Prashant, when I started to think about it, because you find it very hard to find these kind of ideas, or even audience who are interested in talking about these kind of things. um so yeah, I had read a paper on that was a PhD thesis of something, which was why do we need complex valued neural network exactly. So this is a link. Let me share it with you all in chat. So check this link out, guys. Now, so these are some ideas which I wanted to throw in this live stream. The second thing I want to talk about is if you truly want to understand the limitations of a deep neural network, you have to understand more from a cognitive science as well as mathematical side of things. So, for example, let me give you a new term known as concept. So, imagine, I mean, there's no need of imagining things, but think that there is a mosquito in my room, um, and then there is a sibling who is watching you watch me in this live stream. So in this case, what is going to happen? Your sibling or the guy who's in your room and watching you watch this stream has a concept that something like streaming can happen, and streaming is happening, right? But the mosquito in my room has got no concept like that. But the mosquito still is intelligent enough to survive. It is intelligent enough to escape if you try to hit that guy. So these ideas are hard to find in traditional literature. So, and if anybody says that we are at the cusp of deep learning and we are going to learn all the things in deep learning, and there is deep learning in the in the current state is going to rule the world, that's not the case, because deep learning has got no idea of concept. Um, why concept is important? If you have got a concept of internet, if you have got a concept of webcam, if you have got a concept of someone who can talk about things, then you can understand what is happening right now, that I am live streaming. You are intelligent enough to build a complicated system which can actually understand what is happening around you. So it becomes hierarchical. The more concepts you have, the more hierarchically you can knit those things, and you can build new stuff to ease out your life. That's what humans do. But a mosquito don't have these concept. A mosquito has got no concept of streaming. Mosquito has got no concept of webcams. That's why a mosquito, even though it is intelligent in its species, because it is still surviving, if you hit the mosquito, he's going to fly. Call it instinct or call it intelligence, doesn't matter. So that is what my problem is with deep learning claiming to solve intelligence. Which intelligence are you trying to solve? Are you trying to solve um, are you trying to become a mosquito, or are you trying to become a human? Because a human has got these things, a mosquito doesn't, right? Now the other thing is the idea of causality. So there is something known as causality in the deep learning world. Causality, deep learning. So this is a very interesting topic, and I would like to cover it in detail. Let me know in chat if you would be interested in that. So causality is something which talks about relationship between the different data points. So how can we talk about this? So let's say if you give me one data point which says that, or you give me 5 images to train on, the 5 images don't have any interdependencies between them. However, if you have if you are a species who is watching a pendulum um, swing, and imagine that there's a pendulum which is swinging, and on top of the pendulum you have got a light source. At any given point of time, you can let me know how the shadow is, how the shadow will fall. For example, if the light is at the top and pendulum is just at the bottom of the light, your shadow will be beneath and it will be very small, right? And if the pendulum goes this side, the light source is here, the shadow will be a little longer on that side. And why that happens, you also know that, because I'm sure that you have studied physics. um, but that idea of causality is non-existent in current machine learning systems. So if that's the case, then how are neural networks going to rule the world? Because they don't have the idea of causality. So these ideas can be read in Melanie Michel's book. Melanie Michel, she has written a fabulous book. Here's the book: Artificial Intelligence: A Guide for Thinking Humans. Read this book. It's an amazing book. By the way, if you are really interested in exploring these things, join our Discord server, because it's really active community out there, and we have and we will have a lot of training sessions. There's a boot camp which is starting in January, which will focus 6 months specifically on deep learning, and then there are these live streams. So we are trying to build something for Indian community which is not existent. Trying to build a space where we have discussions which are away from fluff. I don't want to tell you that, be a data science enthusiast. You can find a lot on cringin these days. I don't even know what that means. So there is no point on being enthusiast because it's not a sport. It's an important subject for the world. You have to understand cognitive science, you have to understand mathematics, you have to be a good engineer to become somebody who can actually work with deep learning and things. You can build your recommender systems without about these things, but if you truly are interested in learning about artificial intelligence, and if you are interested in learning this subject because you want to solve intelligence, then my friend, you have to read a lot and you have to go beyond what is being circulated in the Indian community specifically. So I hope that you will do that, and we will do it together by talking a lot. This was the first stream which I did. Not sure how good or how bad I did, or how bored you all got, but we'll keep doing it again and again. I'm not going to leave you all. Um, so that's all about today. We are not going to stretch it any long. So thanks for attending, and I'll take your leave now. So drop a bye so that I know that you were here with me till end, and see you all next time. Um, we let me know if you want to, if you want me to do this more often, and next time we can actually, how much work has been done in causality practically? That's a very good question, Prashant. So I'll tell you a data set, pendulum data set. Hmm, what was the name of that? I think this is the data set. The data. Okay, I'm not able to find right now, but if you are on our Discord, I'll drop a message there for sure. So a lot of work is being done, and this is one of the data sets with which you can start. Um, there is a lot of work in the fields of intrinsically motivated reinforcement learning, which also tries to deal with causality. So that is, if you are interested in that, you can start reading about it, because embedding causality in supervised learning settings doesn't make any sense. So I can link this paper, you can check it out. That's all I can talk about right now. Cool. See you all soon. Let's do it more often, and make sure that you are subscribed if you haven't. All right, guys.